All right, here are quiz 1 solutions for Math 65. We're given these two linear equations. So we're given a system of linear equations and asked to find their solution. What can I put in for x's and y's into both of these to make both of these true? And specifically it says to do this by graphing. So the way we'll do that is, we'll do this guy over here. We first want to solve for y. So I can solve for y by maybe subtracting 3y from both sides. And that gives me y plus x minus 5 equals negative x. Maybe I should show where that came from. Let's start from the start. Let's start with 4y plus x minus 5 equals 3y minus x. Now I'm going to subtract 3y from both sides because I want to solve for y, and conveniently that will leave me with exactly 1y over here. And if I subtracted 3y from both sides, this one's gone and I'm just left with y over here. Now I want y all by itself, so I'm going to subtract x from both sides. I used to have negative 1x, I'm subtracting another x, and now I have negative 2x. And then one more step, I want y all by itself, so I want to add 5 to both sides of this equation. And I get y equals negative 2x plus 5. And then we'll take care of this other equation, maybe down here. I got 4 plus 2y minus 3x equals 8 minus x. Again, I want to solve for y. I don't know, maybe add 3x to both sides. That'll give me 4 plus 2y equals 8. And let's see, if I add 3x over here, I used to have negative 1x. Adding 3 more will give me positive 2x. Still want y all by itself, so let's get rid of this 4. Let's subtract 4 from both sides. And I get 2y equals 8 minus 4 is just 4 plus 2x. And now I'll divide both sides of the equation by 2 to leave me with y equals 2 plus x, which I can rewrite as y equals x plus 2, so that it's easier for me to graph, so that it's in y equals mx plus b form. So now I'll graph both of these equations. This one has a y-intercept of 5. 1, 2, 3, 4. Let's see, 1, 2, 3, 4, 5. And a slope of negative 2. So you can think about this slope as negative 2 divided by 1. So I'm going to go down 2 over 1. Down 2 over 1. So if I were to connect all these dots, I'd get a line that looks something like, try to draw a straight line. It's hard to do on a computer. Whatever, good enough. Something like that. And then if I try to graph y equals x plus 2, I got my my y-intercept up here at positive 2, and then my slope is 1, which I can think of as 1 over 1. So I go up 1 over 1, 1 over 1, and I end up with a line that looks something, something like that. Good enough. What's important is that I have an intersection right here. This intersection looks like it's at the point 1, 3. Maybe I can draw an arrow and say that's at 1, 3. So my solution is 1, 3, or x equals 1, y equals 3. Something like that. And question 2, it's actually the exact same thing. Do that 2 more times. Didn't have a whole lot of stuff that we've learned so far, so really just the one topic, so I repeated it twice. Alright, so this first equation, we got 7y plus 8 equals 2x minus 10 plus y. Want to solve for y. Maybe subtract y from both sides. Used to have 7y, now I only got 6y over on this side. And I no longer have this y because I subtracted it from both sides of the equation. I want y all by itself, so let's get rid of this 8 right here. Let's subtract 8 from both sides of the equation. That gave me 6y equals 2x minus 18. And then I want y all by itself, so let's divide by 6. I get y equals 2/6 x minus 18/6, which you can simplify. 2/6 is the same as 1/3, and 18/6 is the same as 3. So what I get is y equals 1/3 x minus 3. And we can do that again with this second equation. I don't know where to put it. I guess I can squeeze it in here. 2y minus 2x plus 2y plus 2 equals y minus 10. Let's see, I have 2y and I have 2 more y. Maybe we should just call that 4y. Minus 2x plus 2 equals y minus 10. I could subtract y from both sides of the equation and get 3y minus 2x plus 2 equals negative 10. And then, see, I guess the order you do it doesn't really matter, but let's add 2x to both sides, because I want the y to be all by itself, and I don't want this minus 2x here. But if I add 2x to both sides, now I have a 2x over here, 2x minus 10. And then finally, I don't want this 2 here, so let's subtract 2 from both sides. Gets me here. Negative 10 minus 2 is negative 12. And then last step, divide everything by 3. So that leaves us with just y on this side. We get 2/3 x minus 12/3, but 12/3 is just 4. So we get 2/3 x minus 4. All right, and then we can graph the two of these guys. So let's do the one in blue first. Y equals 1/3 x minus 3. The y-intercept is at negative 3 here. Negative 1, 2, 3. And the slope is 1/3. So we go up 1 over 1, 2, 3. Up 1 over 1, 2, 3. So our line will look something like that-ish. And then we can do the same thing for the red. Our y-intercept is at negative 4 this time. Negative 1, 2, 3, 4. And our slope is 2/3, so we're going to go up by 2 and over by 3. Nice, it looks like it landed right on one of those dots. So if I connect those dots as carefully as I can, I guess that should be that guy, we get something that looks something like this. So our task is to find the intersection. It's kind of nice it intersected at 2 integers like it did above. Looks like it's negative 2, negative 1, negative 2, 3. So this point right here is at negative 2, comma 3. Or you could say x equals negative 2, y equals 3 if you want. Something like that. And that is the end of the quiz.